In this video, we're going to finish up our object relation mapping example using SQL Alchemy. In the previous video, we set up several classes, team, employees, and manager, in parallel with the earlier Python example we had worked out for setting up classes and objects to represent kind of the human resources or a human resources application that we might use to monitor the state of a company's employees and projects. We were able to use SQL Alchemy to essentially allow our class definitions to also hook into a SQL database where we will actually store the data in a persistent fashion. Now, we're going to create a session from our engine. This session is going to perform the object relation mapping. So far, we've set up the various tables in our database using the engine. Session, we'll see, is going to be responsible for issuing queries as well as adding objects to our database. Session is similar to a Python interpreter, where the interpreter excuse me again. The interpreter is responsible for interpreting our Python code, evaluating any calculations, and returning results. Similarly, Session is going to interpret our Python code through SQL Alchemy into SQL queries and handle interactions to return results from our SQL database to our Python interpreter. So we create a session, and now we're going to set up kind of the various objects that we're going to be working with to add data to the database. So these are similar to what we had in our Python example. We started by making some salaries and degrees. Here we're doing the same thing, but instead of using salary objects and degree objects, we're using dictionaries. So now we're going to get into the meat of the object relation mapping. We're going to create some employee objects, manager objects, and team objects. And remember, since we declared these classes as inheriting from the SQL Alchemy declarative base, these are going to be, we're going to be able to push these objects to our SQL database using the session. So we create our employees, and we create them essentially as we did before. We specify the name, the production, their age. This bit of code, all it does, if I demo it, is we have a little dictionary handling the salary and degree information. And we're unpacking that into keywords of our employee object. So this is essentially as if we were writing salary amount equals 1800, salary period equals 26.0, degree level, etc. To save myself some typing, I've used this somewhat clever dictionary unpacking and dictionary concatenation trick. But the important thing here is that I'm making employee objects just like I did in our previous example when we were working purely in Python. I also make manager objects. For the manager objects, I need to specify all the things I specified for employee, production, name, and age, as well as a capacity. And finally, I make my teams, which looks just like how I made teams in the past. I specify the name and the members of that team. Here, I don't set a manager. Remember, team doesn't have a manager attribute. We're going to, on the fly, calculate who the manager is by simply looking at the members of the team. Once we define all these objects, so when we execute this, we see there's no SQL code getting run yet. But when we add them to the database and commit the changes, we see these SQL queries get executed. So, for example, we inserted into the employees table an employee named Fred, who has an age of 28, a production of 120,000, an ID number 1, team ID number 1. Here's the salary information, and here's the degree information. Interestingly, we only added the tech, sales, and executive objects to our database. But since those objects reference our employee and manager objects, SQL Alchemy automatically inserted those objects into the database as well, because it's aware of all these relationships which we set up in the class definitions. So we also see getting inserted into the managers table are just ID numbers and capacities. We don't insert the entire record for Molly into the manager table. We just have her ID number, which is I'm not sure actually. I guess not shown here. Let's see. Oh, I guess it must be 10. So Arnold is the 9th. Yeah, because the ID numbers are just being generated automatically as they increment, right? We didn't specify any ID numbers here. So Molly is the 10th employee, so she's employee ID 10. Arnold is 9, so he's 9. And they're both managers. Now, where SQL Alchemy shines is, as I said, even though all of this data is stored in a database, we can interact with the data as if they were Python objects. So we can get the members of tech, for instance, and we see there's quite a bit of SQL being executed. There's a SQL query. Select teams ID n as teams ID n, teams name as teams name from teams, and then select employee ID numbers. There's all these aliases. So we're selecting all this from the employees team. And we're selecting where the Yeah, quite frankly, actually, I can't quite make sense of this SQL code. Um, I think what's happening here is essentially we have this join teams ID n equals question mark, and then question mark equals employees dot teams ID number. So I think somehow this question mark is meant to be linked up, and we're just getting essentially a join of team and employee. Employee team ID to team ID. But what we get returned after all this after this SQL query is automatically generated and run, is we get the employees of the tech team, which is exactly who we put in there at the beginning. Fred, Amy, Carrie, Sally. Fred, Amy, Carrie, and then we have here Sally, who we don't quite recognize because she's a manager, so it didn't return her name, but it did give her ID. And if we were to ask for tech members -1, and we asked what her name is, we would see Sally. So this is indeed Sally at the end here. If we were careful and had defined repr methods, oh, we did. Oh yeah, so the repr method for manager simply doesn't include name for some reason. For employee it does. For manager it doesn't. I don't really know why I didn't include it, but there you go. So we can interact with these relations in our database as if they were Python objects. And we can also, if we prefer, issue queries via the SQL Alchemy session to the tables directly. So for instance, if we want to find out what Python object, or construct some Python object corresponding with a filtered table, we could issue a query to that table and apply a filter. So for instance, if I didn't have a tech object already, I could issue a query to the team table, apply some filter, and then pull out that team from whatever the query results are. So here we print out each member in the team for every team returned by the query. Since there's only one tech team, we get a single team back, tech. And then we print out the employees one by one. Alternatively, I could do this again, and I could say something like ID number is less than 2. And then, let's see here. Actually, what was it? Tech, sales, and executive. So less than 3. And then we'll get back 2 tables. And we see I get back the tech table and its employees, followed by the sales table and its employees. And we see kind of like interwoven with those printed results is the SQL code also printed to screen that SQL Alchemy is executing to retrieve the relevant data for this query. Now I can finally show off these hybrid attributes since I've created some of these objects. So even though the tech table, we know, only has an ID and a name stored in it, since it has this relationship with the employees table, and I defined a hybrid property earlier for production, I can calculate on the fly the production of the tech team and whether or not it's healthy. And I don't need to store these in the database. SQL Alchemy is aware of all the relationships necessary to calculate these things from the values stored in the database. What makes them hybrid is we can also use them for queries. So if we have a quick look through sales production and executive production, so the production of the executives is much lower than sales and tech. So say we were interested in the, in teams that produce production greater than 200,000. So this should filter out the executive table, and that didn't work. Why? Okay, so I realized I forgot something, which is that actually to do this, I need to define production as an expression. So this is not something you can do with hybrid properties. I misremembered. But that's okay. I could go back and fix it by defining here. I would from SQL Alchemy dot SQL Alchemy expression. Wow, there is a lot of the word expression here. Import expression. No. Ah, okay, right. So I could do at production dot expression. That's what this would require. And I would just say this hybrid property should, when working as an expression, should do the exact same thing as it does when I'm interacting with it from the object. And that, I believe, would work. But I am not going to take the time to actually check because I would need to restart the kernel and run all this again, and I don't want to do that. To wrap up, I'll just highlight that we can perform kind of our usual SQL operations, filtering, join, aggregation, that sort of thing. So for instance, we can get all the employees with whose names start with A. So that's Amy, and this manager here, who would be Arnold. And we can also do, for instance, joins. So here we are calculating the salary, the total salary paid out to everyone on each team. So it's the total salary paid out to each team. So we're querying, the team. We're querying for team name and total salary, and to get that information, we need to join the employee's team to the team table, and we're going to group this by team name. So we're going to get a result for each team. So the executive team is paid out $100,000 in salaries. Sales team is paid out $530,000. Tech is paid out $286,000. And we didn't need to specify, for instance, kind of like where we were joining on, or we didn't need to specify where we were joining on when we did this join, and the reason is because employee team, when we define the employee class, we had already essentially set up the relationship necessary to do this by having the foreign key into the team's ID, and this relationship team, which is mirrored with the relationship employee in the team class. So kind of the moral of the story here, or to summarize, by putting a bit of work into setting up some a little bit strange classes based on SQL Alchemy, we can simplify a lot of the kind of SQL operations we would want to do for running an application where we need to be constantly retrieving data across different tables and working with that data in the context of a general programming language like Python for running an application. So that's the last lecture of the Introduction to Data Science module. In addition to this week's lecture on object relation mapping, we'll also be having a course conclusion video that will teach you how to download all the course content and share some comments on continuing your learning beyond this course.